Hello everybody and welcome back. In this video we're going to finish off our 2012 grade 7 Gauss paper by examining question number 25. The positive integers are arranged in rows and columns as shown below. So row 1 just has 1, row 2 has 2 and 3, and then 4, 5, 6, and so on. So we're just sort of counting up, and we're trying to keep all the numbers sort of aligned in this triangle shape. Okay? More rows continue to list the positive integers in order, with each new row containing one more integer than the previous row. Okay? Row 3 has 3 numbers in it. Row 4 has 4 numbers in it. And 4, I'm sure you'll agree, is one more than 3. Yeah, that rhymed. Okay, how many integers less than 2,000 are in the column that contains the number 2,000? This is kind of odd. Why wouldn't they go with 2012, the year of the contest? Oh well. So how many integers less than 2,000 are in the column that contains the number 2,000? So it might be a good idea for this question for us to be able to determine what row and what column numbers are in. It's kind of interesting. They've got the rows. They don't do columns. Column 1, column 2, column 3. But I suppose we could add that in. Okay. So how do we work out what numbers are where and what numbers are in the same column and that sort of a thing? Okay, so looking at small things, suppose we were looking for 13. Is there a way to know that 13 is in the 5th row in the 3rd column and that it's got 2 numbers above it? Well, if I'm in the 3rd column, just thinking here, I'm going to be able to have numbers above me until I hit the 3rd row, because the 3rd row is where the 3rd column starts, just like the 2nd row is where the 2nd column starts. So that's kind of interesting. So if 2,000 is in column X, well, let's say column C, and row R, okay, there will be, I think, C minus R. No, R minus C, because R should be the bigger number. R is always bigger than or equal to C. So R minus C numbers above it. Okay? Because there's the number in, so we imagine row R here, and here's 2,000. There'll be a number above it in row R minus 1. There'll be a number above that in row R minus 2. So now with R minus 2, we've got 2 numbers all the way up to row C, which happens to match my column. And there's nothing above that one. It's blank above it. Okay? So the difference between R and R minus 1 is 1, and there's 1 number above 2,000. Difference with R and R minus 2 is 2, and there's 2 numbers above it. So it should be R minus C tells me the numbers above 2,000. So all I need to know is what row is 2,000 in and what column is it in. Okay. How can I figure out what row a number is in? And this is a trickier thing. So depending on how versed in math contests you are, you may or may not recognize some very special numbers here at the ends of the rows. 1, 3, 6, 10, 15. These are numbers called triangular numbers. Okay? The reason they're called triangular, the ancient Greeks loved making shapes with numbers. So if you have 1 dot, that's sort of a 1 triangle. But if you have 3, you can make a triangle. If you have 6, you can make a triangle. Nice equilateral triangles here. 10 and 15 and so on. Okay? So we might recognize, oh, the rows end with triangular numbers. And in fact, 10, the last number in row 4, is the 4th triangular number. 6 is the 3rd triangular number. 3 is the 2nd triangular number. So an observation we could make, row R ends with the rth triangular number. Okay, and if you're unsure of triangular numbers, it's something that you may wish to look up because they do pop up on math contests. Even if I noticed this, how is this going to help me? Sure, row R ends with the rth triangular number. So what? How does that help me find where 2000 is? What row is 2000 in? What column is 2000 in? Okay? Well, there's a real nice formula for our triangular numbers. Notice 10 has one dot at the top, then 2, then 3, then 4. That's how you get 10. 6 is 1, 2, and 3 dots. 1 plus 2 plus 3 is 6. 1 plus 2 plus 3 plus 4 is 10. 1 plus 2 plus 3 plus 4 plus 5 is 15. So the rth triangular number is the value 1 plus 2 plus 3 all the way up to plus r. Okay? You say, okay, that's an expression. I thought you said you had a formula. So there's a very nice formula for the sum of the first r numbers, our first r natural numbers. It's r times r plus 1 all over 2. And it's a very good one to have sort of committed to memory. Okay? It does pop up on math contests, especially some of the harder questions. Now, just very briefly, why is this? Well, let's suppose I looked at my 10 triangle a different way. Okay? And I swear I'll get back to the question. So here's my 10. If I take this triangle and I write it upside down, I have 10 blue dots, 10 red dots, right? So I've got 2 times my number. Let's call it n. 2 times 10. Okay? 2 times the fourth triangular number. Now, these dots are arranged as a rectangle with dimensions n, dimensions 4, which in this case is r, because I'm looking at my rth triangular number. 10 is the fourth triangular number. And then we get 4 on the bottom plus the 1 blue dot. So this should be r times r plus 1. Okay? And then if I just want my number 10, I divide by 2. Okay? R times r plus 1 over 2. This is how you actually show the formula for triangular numbers. This is how you add up the first 10, the first 15, the first 28, the first 586 numbers. Okay? Is with this formula, and this is how you prove it. Okay, fine. So, the rth triangular numbers r times r plus 1 all over 2. That gives me a nice formula for these end numbers. Okay? And we can try and work out which row 2000 is in, because 2000, if 2000 is in row r, it's going to be somewhere, and then it's going to be end that row with r times r plus 1 over 2. And since the numbers are increasing in the row, we need to look for an r satisfying this expression. Okay? Or you could say r times r plus 1 must be greater than 4000. Now, r and r plus 1 are really close numbers to r squared. I don't want to solve expressions like this on a grade 7 paper. But I can say, oh, r squared must be about 4000. Maybe it's not bigger, but maybe r times r plus 1 is. But now I could grab my calculator and say, hey, what's the square root of 4000? And I see it's about 63. So I might try the 63rd triangular number, the 62nd, or maybe the 64th. But that should be about the row that 2000 is in. So let's try the 62nd, the 63rd, maybe even the 64th. Okay? So the 62nd triangular number is going to be 31 times 63 when you work it out. And that's going to be 1953. That's a little too low. What about 63 times 64? All over 2. Well, that's 2016. That's just bigger than 2000. Okay? So I don't really even need this one. Okay? So I know the 64th row, 63rd row, looks like this. So the last row, 62nd row, blah, 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 ends with 1953. So this row will start with 1954. It'll keep going for a while, then it'll get 2000, 2001, all the way up to 2016. And so this number is really close to 2000. I could just sort of count backwards, couldn't I? Or we could write them out. We can actually write out our row here. I'm going to have to go down to the next line. Okay. Oops. 12. 2012 is the one they should have made it. Okay. So this is how the 63rd row sort of looks if it was all on one line. Okay. So it's 2000, we know it's in the 63rd row, and 2016 should be in the 63rd column, right? Because remember, 6 is in the 3rd row, 3rd column. The last number is in the whatever row and whatever column. Okay, so 63rd column, 62nd, 61, 60, 59, 58, 57, 56, 55, 54, 53, 52, 51, 50, okay. 49, 48, 47. So 47th column. Okay. So there we go. You didn't have to write it all out. I just figured while I was there. I mean, you'd really just need to subtract the difference in these numbers from 63. So 63 minus 16 is 47. Okay? So 2000 is in the 63rd row and the 47th column. How many numbers are above it? Well, you take the row number and minus the column number, and you get 16. There you go. And 16, that's an answer of D. Okay? And had we been a little bit cleverer, we could have noticed that a lot sooner. We wouldn't have had to mess about earlier with this sort of expression and this, oops, where was it? Yeah, we wouldn't have had to mess about with this sort of stuff. Okay? Because we could have just said, okay, for this number, the number of numbers above it are the same as the number of numbers to the right of it. And so 2000 all the way up to 2016, how many numbers are to the right? 16. So that would have been a slightly faster way. I didn't see that right away, but that's okay. We still get our answer of D, 16. And if you're curious and you want a nice little formula to work with, you know, experiment on your own, show that this formula works. The number in row R and column C should be what? Okay. Well, you're going to take the number, the last row number in the previous row is this expression, and then you're going to add on your column number. Okay. So try and show why this formula works. Okay. Use it to double check that, yeah, $2,000 really is in the 63rd row and 47th column. Okay? Maybe even try and show that that expression is always unique for any R and C less than or equal to R. Okay? But I think that's it for me, because that's going to wrap up the whole contest there. A little bit of a harder question. Definitely things that you might want to know and take from here going forward. Definitely this idea of triangular numbers, recognizing the 1, 3, 6, 10, 15, but also that formula. N times n plus 1 all over 2. This is a very, very important formula, and you're going to see it if you do more math contests. I guarantee you. Okay? But that's it for me, as I say. I'll see you for more math in the future, whatever math contests you get up to. And yeah, have yourself a wonderful day.